Hello everyone, this is Preet Kanwal. I'm a lecturer at Mehchan Polytechnic College, Jalandhar. Today, I will be sharing with you an important information that is related to Mission Fateh, a campaign run by our worthy Chief Minister of Punjab, Captain Amrinder Singh, who says that we should fight with this pandemic situation very carefully, and by taking some small precautions we can fight against coronavirus. That is to wash our hands regularly, to use mask, sanitizer, and to maintain the social distancing. So these are some precautions that if we will take care of regularly, then we will definitely be able to avoid the coronavirus. So let's move on to the topic, and that is related to the PLC programming language that we will be discussing today. And in this PLC programming language, today I will be telling you about the programming languages that are being utilized in the PLCs, that is in the programmable logic controller, as we have discussed in the last lecture about the PLCs. That here we had discussed that how the PLCs are important, how they have overcome the limitations of the relays, and how they are there in the industries nowadays, and they can function in a variety of noisy environments. In the industrial environment, they're specifically designed computers for this particular purpose in the industrial areas, and there are having numerous of advantages. Now we will be discussing about the programming languages. Here I will tell you about the different languages that we are using for programming the PLCs, and from which only the ladder diagram programming was being very popular among them. We are having, say, you can see over here that we are having different programming languages. I hope you all can see my board, and this is all visible to you all, right? This is the PLC programming language. We can divide them into two parts. First one is the alphanumeric display, and the second one is the graphic display. In the alphanumeric display, as you can all see, the name suggests that is alphanumeric. That means in this, alphabets and numerals are used for the programming purposes, and here the graphical display is used for the programming purposes. Whereas the graphic display is further classified into two types, that is the state oriented and the process oriented. So let's first discuss about the alphanumeric display. In the alphanumeric display, the first one is the instruction list and the second one is the structured text. When we talk about the instruction list, then as the name suggests, it means that it is a low level textual language. As it is the instruction list, so that means in this we will be using the instructions, right? So in the instructions, they are like program. The programming will be done like the instructions. It needs the minimum memory space. It is having a fastest execution, as it is in the form of a list, in the form of the instruction list that will be given inside the programming language. Then, but there is a problem. As you can all see, I have written here UE 2.3, UE 3.7. These are all the instructions that have some meaning, right? But we are unable to understand or unable to read it properly. It is very difficult to understand. So it is just suited for some small straightforward problems. If we have to make programs for some small and some straightforward problems, then only this instruction list could be used. It cannot be used for the difficult program, as it is difficult to understand. So it will become very difficult for us to make it, or to support the structured programming. It will not be able to support the structured programming. So that is why it is very difficult to understand. It will be very difficult for us to find out some problems, or any in case of any complex instructions, if we will be using for any complex programming or very long programming, it cannot be utilized. So that is why let's shift out to, in the alphanumeric display, we shifted out to the structured text. In the structured text, what happens is it is a high language textual programming language, right? As the instruction list was the low level programming language, it is the high level programming language. And it's the high level programming language like Pascal or basic C that we use the languages. It is very flexible, it is very intuitive for the wiring control, for writing the control algorithms, right? But it is considered as the modern programming language, and the people having knowledge of it will be doing this computer task, will be doing these programming languages very easily. It is very easy, and it can be used as a text editor also, right? So it is best suited for the process of programming complex mathematical algorithms or the decision making problems. It is the best suited for that kind of a programmings, right? So in the alphanumeric display, the instruction list is least used as the low level language, but structured text is mostly used in case of alphanumeric display. So let's move on to the graphic display. In the graphic display, we have already divided into two types, that is state oriented and process oriented, right? In the state oriented, we are having two types of languages. First one is the functional block diagram, and the second one is the ladder diagram. In the functional block diagram, what happens here is we are having functions, we are having blocks of the functions. Whatever the function we have to perform, whatever the program we have to perform, we draw it in a kind of a block diagram, as we all draw a diagram. Similarly, in this kind of a language, is this kind of a programming language, on the computer screen, on our programming screen, we just draw these kind of blocks. As like, for example, you can see here, this is the AND operation I have written in the block, and for ANDing operation, what we have to do, we have to give two inputs and there is one output. That one output is given to greater than or equal to block, and here another input is given, that is A 2.1, whatever will be the input that will be given to this block, and it will compare greater than or equal to, and then it will give you the answer. So like this, in this format, this functional block diagram works. It is basically a graphical programming. We don't have to write any instructions, as like in the structured text or in the instruction list we have to write the programming, that we have to do dot equal to, or colon equal to, or we have to do the ANDing operation or whatever, we have to write it. But here it is a graphical display programming, so that is why here we will do only graphical design. Graphical programming will be there, we will do the designing. It is most probably like the flow chart diagram we all do in our C language, right? So through different blocks and the functions we can generate the output. Then the next one, in the state oriented graphical display languages, the second one is the ladder diagram. The most popular programming language that is being utilized for programming the PLCs is the ladder diagram, and in the ladder diagram we uses these kind of components in between. This is used for the motors or the outputs or the lamps, and these are the gates. Basically the symbols of the gates are being utilized, whether we can use a NOT gate or AND gate or OR gate or XOR gate or whatever the gates are, we have defined symbols for the gates, and whatever the operation we have to perform, it is like a ladder. It is like a ladder, means the CD. It is like a ladder, and we make the program like a ladder only. We just have to put on whatever the number of inputs. If we want to do the ANDing operation or the ORing operation, we just have to put in here the component diagram. That's it. The symbol of the component that is used in the programming, PLC programming, for ANDing operation, for ORing operation, whatever there will be, for NOT operation, whatever there will be the symbol of that particular gate, we have to just mention it here, and along with that this symbol is used for the motor output or the lamp output or like that. So this kind of a ladder diagram programming, which is the most popular one, which has replaced the relay control systems, and there is no need of any kind of training for learning this programming, ladder diagram programming. We do not need any kind of trained programmers. A basic programmer or a basic student, you all can do this ladder diagram programming so easily that it is the main programming method. It is just the twin of, we can say, the relay logic diagram. If any electrician or any person who knows about the electric things, who knows about the relay logics, he or she can do this ladder diagram programming along with that those logics in their mind. So it is also a low level graphical language, but it is not suited for programming the complex instructions, but still it is the most popular diagrammatic graphical display language that we are using nowadays for programming our PLCs. The last one under the process oriented is the sequential function chart. It is basically the sequential function chart. As the name suggests, it is a functional chart. It is basically a functional chart in which a sequence of instructions is being used. It is like a chart. It is a high level graphical programming language that is developed to accommodate programming of more advanced systems. Programming, it is being utilized for them, and it is similar to the flow chart, like the pictorial representation of the sequence of events involved. Here you can see the sequence of the events have been involved in this process, and the process is described by number of separate sequentially connected states of steps. The different steps are connected, they are connected sequentially. It is like a chart. As we form a chart, it is represented in rectangular boxes, and a particular state of control is being represented in the form of a chart, in the form of a basic sequences, right? So in a sequence, in the form of a chart, in the form of a pictorial representation, in the form of number of separate sequentially connected devices or states or steps which are represented by the rectangular box. This is all done by the sequential function chart. So this is all about the PLC's programming languages. We are having basically, it is the PLC programming language is classified into two points, that is alphanumeric and the graphic display. In the alphanumeric display, we use alphabets and numerals for the programming, and in the graphic display we use the graphical representation. That may be a functional block diagram, that may be the ladder diagram, or that may be the sequential function chart, but we will be doing our programming in the form of graphics, in the pictorial representation. As I always say, that whenever there is something written in long English lines or Hindi lines or in any language, when it is written, then it is very difficult to understand, or we do not even create interest in reading those lines or those long syntaxes. But whenever we talk about the diagrams, whenever we talk about the graphical representation of anything, then it becomes more easy for us and more interesting for us to understand as well as to learn those things. So that is why the PLC programming language has put their self into the graphical display, in the graphical programming language, so that anyone could understand it and anyone could perform any kind of a program on these kind of languages. So let us now discuss about the applications of the PLC. This was all about the programming languages. Now let us all discuss about the applications of PLC, that is how and where the PLCs are being utilized. The first application where the PLCs are utilized in the industries, as we have already discussed, that the PLCs are specifically designed computers for the industries, for industrial purposes, industrial automation. Then which kind of industries are using PLCs? The first one is the conveyor system. Conveyor system means it controls all the sequential operations, alarms and safety logics, as like conveyor belt, controlling that conveyor belt, that when to start, when to stop, wherever to pick or place something on that conveyor belt to give some time, some delay, or some alarm is to be set, or some safety measures are to be taken care. So all these things are done with the conveyor system, and this is all controlled by the PLCs. Then after is the production machines. Then in the production machines, in the industrial areas, in the production machines where the controls and monitoring operations, the automatic productions are being happening, in those kind of packaging machines we use the PLCs. Then in IC engine monitoring means the analysis, the data records, and the sensors which are being utilized in the monitoring purposes. There also the PLCs are being utilized in the paint spraying purposes, in loading and unloading of the alloys, in the chemical batching, in oil fields, power plant systems, automated warehousings, and glass batchings, and so on. Numerous of applications are there of the PLC in most of the industrial areas, in most of the industries. We basically use these PLCs nowadays, and all the automation in the industries is dependent upon the PLCs nowadays. So last point is our PLC manufacturers. What do you mean by PLC manufacturers? Means how and how many companies are manufacturing PLCs nowadays. Nowadays PLCs manufacturers are a lot, as like Allen Bradley, Siemens, Texas, ABB, Messung, Cutler, Modicon, and a lot of manufacturers are there. Numerous of manufacturers are there who are manufacturing PLCs nowadays. But in Indian industry, we are using Allen Bradley and Siemens PLCs, which are most popular because of their variety of output ranges and their best operation in the industrial areas. So this was all about the PLCs, the programmable logic controller. I hope you all are clear about this programming languages, the applications, and the PLC manufacturers that we have discussed today in this lecture. If you will be having any doubts, any queries, we will be clearing them in our live sessions. Thank you so much.